Question 1. Scenario. A SOC hunter writes a custom KQL query to search for rare parent-child process combinations and wants to run it periodically and be notified if new matches appear, without converting it into a full analytics rule that creates incidents. The question is, what is the most appropriate approach in Microsoft Sentinel? Your options are: Option A, convert it into a scheduled analytics rule immediately. Option B, save it as a hunting query and periodically review results, or livestream it for real-time monitoring. Option C, delete the query after each use. Option D, use it only as an RSA rule. Take a moment to think about your answer. The correct answer is B, save it as a hunting query and periodically review results, or livestream it for real-time monitoring. Why B is correct? Saved hunting queries in Sentinel can be run manually or reviewed periodically, and Sentinel's livestream feature allows real-time monitoring of a query's results without formally creating incident-generating analytics rules. Why A is wrong? Converting to a scheduled analytics rule immediately would generate incidents, which the hunter explicitly wants to avoid at this exploratory stage. Why C is wrong? Deleting the query after each use forces the hunter to rewrite it every time, losing reusability. Why D is wrong? RSA rules are defender for endpoint attack surface reduction controls. They cannot execute custom Sentinel KQL hunting logic. Question 2. Scenario. During a hunting session, an analyst finds a particularly interesting set of query results showing a rare process spawning pattern and wants to save this specific finding for later reference and potential escalation to an incident. The question is, what should the analyst use? Your options are: Option A, a hunting bookmark. Option B, a workbook pinned tile. Option C, a data connector. Option D, an RSA rule exclusion. Take a moment to think about your answer. The correct answer is A, a hunting bookmark. Why A is correct? Bookmarks in Sentinel hunting allow analysts to save specific interesting query results, along with notes and tags, for later reference, and bookmarked items can be added to an incident for further investigation. Why B is wrong? Pinning to a workbook is meant for building recurring visualizations, dashboards, not saving a specific one-off investigative finding. Why C is wrong? Data connectors manage data ingestion sources. They have no role in saving hunting findings. Why D is wrong? RSA rule exclusions are an endpoint protection configuration, unrelated to saving hunting query results. Question 3. Scenario. Your organization ingests a very high volume of low-fidelity firewall logs that are rarely queried individually, but are occasionally needed in aggregate, e.g., total connection counts per hour by source IP, for trend analysis, and you want to reduce ongoing query costs. The question is, what Sentinel feature should you use to pre-aggregate this data cost effectively? Your options are: Option A, a hunting bookmark. Option B, a Sentinel playbook. Option C, a custom RSA rule. Option D, a summary rule that pre-aggregates data into a smaller summary table on a schedule. Take a moment to think about your answer. The correct answer is D, a summary rule that pre-aggregates data into a smaller summary table on a schedule. Why D is correct? Summary rules run on a schedule to pre-aggregate high-volume data, like connection counts, into a smaller, cost-effective summary table that can be queried quickly for trend analysis without repeatedly scanning the full raw dataset. Why A is wrong? Bookmarks save specific investigative results. They do not pre-aggregate large volumes of raw data. Why B is wrong? Playbooks automate response actions via logic apps. They are not designed for data aggregation, summarization. Why C is wrong? RSA rules are an endpoint protection feature entirely unrelated to log data aggregation. Question 4. Scenario. A data engineer on the SOC team wants to run large-scale, long-running KQL transformations against archived data in the Sentinel data lake tier, beyond what interactive query timeouts typically allow. The question is, what should they use? Your options are: Option A, a Sentinel workbook; Option B, an automation rule; Option C, a KQL job in the data lake tier; Option D, an ARSA rule in audit mode. Take a moment to think about your answer. The correct answer is C, a KQL job in the data lake tier. Why C is correct? KQL jobs in the Sentinel data lake tier are designed for large-scale, longer-running asynchronous query and transformation operations against lake tier data, exceeding the constraints of standard interactive queries. Why A is wrong? Workbooks are for interactive visualization dashboards, not long-running large-scale data transformation jobs. Why B is wrong? Automation rules act on incidents for response workflows, not large-scale data lake query processing. Why D is wrong? ARSA rules are an endpoint security control, entirely unrelated to data lake query processing. Question 5. Scenario: your SOC's data science team wants to apply custom Python-based machine learning models to hunt for anomalies across large datasets in Microsoft Sentinel, integrating both KQL queries and Python code in a single reusable workflow. The question is, which Sentinel feature should they use? Your options are: Option A, Sentinel notebooks, Jupyter-based; Option B, Sentinel workbooks only; Option C, ARSA rules; Option D, data connector health monitoring. Take a moment to think about your answer. The correct answer is A, Sentinel notebooks, Jupyter-based. Why A is correct? Sentinel notebooks, built on Jupyter, allow analysts and data scientists to combine KQL queries with Python code, external libraries, and machine learning models in a single reusable, shareable hunting workflow. Why B is wrong? Workbooks support KQL-driven visualizations, but do not support custom Python code or ML model integration like notebooks do. Why C is wrong? ARSA rules are an endpoint protection feature, entirely unrelated to data science hunting workflows. Why D is wrong? Data connector health monitoring tracks ingestion pipeline status, unrelated to custom analytical notebooks. Question 6. Scenario: an analyst using a Sentinel notebook wants to query live incident and entity data directly through natural language-assisted interactions, connecting the notebook environment to Sentinel's back-end context in a standardized way for AI tool integration. The question is, what underlying capability enables this kind of standardized connection between hunting tools and Sentinel data? Your options are: Option A, attack surface reduction rules; Option B, DLP policy matching; Option C, Azure policy deploy if not exists; Option D, connection to the Sentinel MCP server, which exposes Sentinel data, tools in a standardized way for AI-assisted hunting. Take a moment to think about your answer. The correct answer is D, connection to the Sentinel MCP server, which exposes Sentinel data, tools in a standardized way for AI-assisted hunting. Why D is correct? The Sentinel MCP, Model Context Protocol, server exposes Sentinel's data and capabilities in a standardized interface, enabling notebooks and AI-assisted tools to query and interact with incidents, entities, and hunting data consistently. Why A is wrong? ARSA rules are unrelated to data connectivity or AI tool integration. They are an endpoint protection mechanism. Why B is wrong? DLP policy matching concerns data loss prevention, not standardized data connectivity for hunting tools. Why C is wrong? Azure policy deploy if not exists is used for automated resource compliance, configuration, not for connecting hunting tools to Sentinel data. Question 7. Scenario. A hunter wants to build a hunting query that periodically checks for a spike in failed sign in attempts across the environment and wants the query to run automatically every hour and surface a livestream notification without creating a full incident. The question is, what Sentinel hunting feature should they use? Your options are: Option A, scheduled analytics rule set to create incidents. Option B, hunting query livestream. Option C, automation rule with playbook trigger. Option D, data connector configuration. Take a moment to think about your answer. The correct answer is B, hunting query livestream. Why B is correct? The livestream feature in Sentinel Hunting lets analysts run a hunting query on a near real-time recurring basis and receive session notifications of new matching results, without formally converting it into an incident-generating analytics rule. Why A is wrong? A scheduled analytics rule set to create incidents does exactly what the hunter wants to avoid, generating full incidents from every match. Why C is wrong? Automation rules act on already created incidents. They don't provide a mechanism for live hunting query monitoring itself. Why D is wrong? Data connector configuration manages ingestion, not periodic hunting query execution or livestream notification. Question 8. Scenario. An analyst wants to periodically rerun a set of 10 related hunting queries covering different stages of a suspected supply chain attack, and track overall progress and coverage against those hypotheses in one place. The question is, what is the best practice using Sentinel's hunting dashboard? Your options are: Option A, manually retype each query every time from memory. Option B, convert all 10 queries into RSA rules. Option C, save all 10 as named hunting queries, tagged appropriately, e.g., by MITRE tactic, and review results together in the hunting blade. Option D, delete 9 of the 10 queries to simplify tracking. Take a moment to think about your answer. The correct answer is C, save all 10 as named hunting queries, tagged appropriately, e.g., by MITRE tactic, and review results together in the hunting blade. Why C is correct? Saving related hunting queries with descriptive names and MITRE ATT and CK tactic technique tags in the hunting blade allows the analyst to organize, rerun, and track results of a multi-query hunting hypothesis in one consolidated view. Why A is wrong? Manually retyping queries from memory is inefficient and error-prone compared to saving them for reuse. Why B is wrong? RSA rules are unrelated to Sentinel hunting query management. They are an endpoint protection feature. Why D is wrong? Deleting 9 of 10 queries discards valuable hunting coverage across different stages of the suspected attack. Question 9. Scenario. A hunter needs to combine hunting query results from Sentinel with external threat intelligence data retrieved from a REST API, and apply custom statistical analysis not available natively in KQL, as part of an ongoing proactive hunting program. The question is, which tool provides this flexibility? Your options are: Option A, Sentinel notebooks, using Python libraries alongside KQL magic commands. Option B, a Sentinel workbook with static KQL panels only. Option C, an RSA rule in block mode. Option D, a DLP policy. Take a moment to think about your answer. The correct answer is A, Sentinel notebooks, using Python libraries alongside KQL magic commands. Why A is correct? Sentinel notebooks support KQL magic commands alongside full Python capability, including REST API calls and statistical ML libraries, giving hunters the flexibility to combine Sentinel data with external sources and custom analysis. Why B is wrong? Static KQL-only workbook panels cannot make external REST API calls or apply custom Python-based statistical analysis. Why C is wrong? RSA rules are an endpoint protection feature, entirely unrelated to combining external threat intel with custom analysis. Why D is wrong. DLP policies enforce data protection rules. They have no hunting or external data integration capability. Question 10. Scenario. Your organization wants to reduce the cost of running the same expensive aggregation query against raw high-volume device network events data every day for a recurring executive report, while keeping the underlying raw data available for ad hoc investigations. The question is, what is the best long-term solution? Your options are: Option A, delete device network events data older than 24 hours. Option B, move device network events entirely to the basic ingestion tier. Option C, create a summary rule to pre-aggregate the daily metrics into a summary table, while keeping raw device network events at its current tier for investigations. Option D, run the aggregation query manually each day via a hunting bookmark. Take a moment to think about your answer. The correct answer is C. Create a summary rule to pre-aggregate the daily metrics into a summary table, while keeping raw device network events at its current tier for investigations. Why C is correct. A summary rule can pre-compute and store the recurring aggregation in a small, cheap-to-query summary table on a schedule, reducing daily query costs, while the raw device network events table remains fully available at its current tier for detailed ad hoc investigation. Why A is wrong. Deleting raw data after 24 hours would eliminate the ability to perform ad hoc investigations into older network activity. Why B is wrong. Moving to basic tier severely limits query capabilities, no analytics rules, limited KQL, on data needed for ad hoc investigation. Why D is wrong. Manually running a bookmark query daily is not automated, does not reduce cost, and doesn't produce a persistent optimized summary table. Quiz complete. You have reviewed all questions and their full explanations. Great work. Please like and subscribe my channel for more such contents.